Ever pondered the inner workings of a generator or a motor? Or perhaps you found yourself curious about the unseen forces that make your induction cooktop heat up your dinner? Well, there's a fascinating principle known as Lenz's law at play behind these everyday mysteries. Lenz's law is a cornerstone of electromagnetism, dictating the direction of the induced electromotive force, or EMF, produced by a shifting magnetic field. In layman's terms, Lenz's law tells us that any induced current will always flow in a direction that counters the change that sparked it. Now you might wonder, why does it behave this way? The answer lies in the principle of energy conservation. A change in a magnetic field does work on nearby conductors, triggering an electric current to flow. This current then generates its own magnetic field, which stands in opposition to the change in the original magnetic field. This resistance is what stops the initial change from happening too rapidly. Lenz's law finds a multitude of applications in the world of electronics, from generators and motors to transformers and induction heaters. It also plays a crucial role in understanding the behavior of inductors and capacitors. Diving deeper into Lenz's law, we find that an EMF is induced in a conductor when it moves through a magnetic field, or when a magnetic field fluctuates around a stationary conductor. The strength of this induced EMF is directly proportional to the rate at which the magnetic flux alters through the conductor. And the direction of this induced EMF? It's such that the current it generates creates a magnetic field that opposes the alteration in the original magnetic field. Take a generator, for instance. A generator comprises a coil of wire rotating between two magnets. As the coil spins, the magnetic flux flowing through the coil varies, inducing an EMF in the coil. This induced EMF then sparks a current in the coil, which can be harnessed to power a circuit. Or consider a motor. A motor includes a coil of wire positioned within a magnetic field. When a current is applied to the coil, the magnetic field generated by this current interacts with the external magnetic field. This interaction gives rise to a torque that sets the coil in motion, allowing the rotating coil to power a mechanical device. So, to recap, Lenz's law is all about how induced currents always oppose the change that caused them, a principle that underpins the workings of many electrical devices. From generators and motors to induction heaters and transformers, Lenz's law is at the heart of these mechanisms, making our modern world go round.